What's up, Cloud people? I am going through the SageMaker Canvas marketing workshop today, and this content is available to everyone at workshops.aws. Says here, available for access anywhere, globally available without restriction and mobile friendly. As a disclaimer, I do work for AWS, but this is just my private channel, so I'm not representing AWS on this channel, and any opinions stated are my own. All right, so diving into it, Amazon SageMaker Canvas is a service that lets you do machine learning without writing code. And if you go to workshops.aws, you can follow along. So you can type in Canvas in the search bar and then get started. And I'm just going to run through the Canvas for marketing example here, customer churn, and feel free to follow along, ask questions in the chat. If you get stuck, happy to try to help. And I'll just walk through this and hopefully it helps you. Now, before you follow along, you'll want to go to the prerequisites of the self-paced lab and follow these steps. I won't go through these steps today, but you can find them here. These are available to the public. Okay, so in the overview here, I'm just going to read through this and you can skip ahead using the timestamps in the description. In this lab, we assume the role of a marketing analyst in the marketing department of a mobile phone operator. We have been tasked with identifying customers that are potentially at risk of churning. We have access to service usage and other customer behavior data and want to know if this data can help explain why a customer would leave. If we can identify factors that explain churn, then we can take corrective actions to change predictive behavior, such as running targeted retention campaigns. Basically, why is a customer leaving? So, you could use other ways of predicting other than machine learning to estimate or to try to predict whether a customer is going to leave or not. There are things you can do with statistics and spreadsheets. However, with machine learning, the cool thing is explainability. You can figure out which columns or features, such as day charge, customer service calls, which of those impact that prediction to what degree. So you might come up with things that way that you didn't think of are impactful. For our dataset, we use a synthetic dataset from a telecommunications mobile phone carrier. You can download it here. Okay, I will download that. This sample dataset contains 5,000 records, where each record uses 21 attributes to describe the customer profile. The attributes are as follows. Okay, I won't read through each one of these right now. You can read through them. Your marketing team has informed you that this column indicates whether the customer left the service, true or false. The last attribute, churn, question mark, is the attribute that we want the ML model to predict. So basically, we want it to be able to give all these other attributes and then have the model provide us with the last attribute, true or false. Is the customer going to leave or not? The target attribute is binary because it's only two options, true or false, meaning our model predicts the output as one of two categories. Okay, we're moving on to the first step. Import the dataset in Canvas. Go back to the SageMaker Canvas tab created in the prerequisites lab. Again, if you haven't done this, go to self-paced lab and follow those instructions. On the left menu, you can click the second icon to head to the dataset section. So I am going to skip the welcome part of Canvas. And now I'm going to click the import button. We're going to select upload and we'll drag the CSV file we downloaded in the previous step and we will see a preview. So let's do that now. Okay, so I have selected the churn.csv file and now I will hit preview, and this gives us a nice taste of what this data looks like. Includes the charges per night, calls per night. And if this looks good to you, you can actually import the data. Depending on the size of the data set, it can take about 10 seconds or so to import. And then it'll be in the ready status when it's complete. And looks like ours is already in the ready status. Now we're able to move on to step 2 of creating a model, which is the build. So let's go to the model section on the left here and click new model. And we'll call this customer churn. You can call it whatever you want and create. In the model view, you will see 4 tabs, which correspond to the 4 steps to create a model and use it to generate predictions. Select, build, analyze, predict. Select, build, analyze, predict. So currently we're in the select stage. So the churn.csv file is already selected, I think because it's the most recent addition to the datasets in our Canvas environment. So I'm going to hit select, and that immediately takes us to the build step. And we'll choose a column to predict. I'll just type that in to find it faster. And very nice. The value distribution is very nice and even, false and true, about 50-50. And Canvas immediately recognizes that the model classifies churn into 2 categories. Therefore, it says, we recommend to do a 2-category prediction, aka binary. And from this selection, we can already see that the target variable is well distributed. Yep. And this means that we don't have to do any additional operation of undersampling or oversampling on our data set. And our model is going to learn equally from both classes. Build data exploration. Before we even get started training our model, let's have a closer look at our churn prediction dataset. In the Build tab, you can start analyzing visually your dataset. The 2 views that are available are column view and grid view. So by default, we have the column view, and I just switched it over to the column view, which is a nice way to see the distribution via a graph. And in the column view, we can easily see if there are any missing values in a column, or if there are any values in that column that don't seem to belong. And this is a good view if you want to drop a column, and you can do that by unchecking it. And it'll tell you, okay, we're going to drop this column that you deselected. In grid view, you can check the data distribution and some data samples from your dataset. For more advanced visualizations, SageMaker Canvas offers a data visualizer that can help you to gain advanced insights into your data before building your ML models. You can visualize using scatter plots, bar charts, and box plots, which can help you understand your data and discover the relationships between features that could affect the model accuracy. Let's try that out. There's the data visualizer, and let's drop just randomly night mins, and then we drag a different one into the other axis, and there we get a scatter plot. We can also do a bar chart. Oh, and it'll tell us if the data type is supported or not. And we can do a box plot. And we can choose how many rows to use as our random sample for creating these graphs. Okay, so let's start by creating a simple scatter plot. Let's say that we would like to see how charging more impacts the number of minutes a customer phones. To create this visualization, drag and drop the features onto the plot axis. We're going to use day mins on the x-axis, day charge on the y-axis, and churn on the color by feature. We can see that customers who churn are customers who are charged more, especially if they call for a longer time, greater day mins. Okay, so let's go back to data visualizer, select scatter plot. We'll put day charge on the y-axis. Let's find that. Here we go, day charge. And we'll put day mins on the x-axis. And where is color by? Here we go, bottom left. Oh, and we can just drop it into the color by box. So that'll be churn question mark. So we can just drag that churn into the color by box. And it looks like on first glance that there's less customer churn, the purple, as opposed to the red, in the left here, which is where the day mins are less. So I guess for reservations where people stay shorter, there's less customer churn. Let's try to plot the frequency of customer service calls according to the state and how they impact churn. For that, we will create a bar plot with state on the x-axis, customer service calls on the y-axis, and stacked by churn. So I'll select bar chart and customer serve calls on the y-axis and state on the x-axis. I guess those are US states. And then stacked by, that's on the right lower part of the screen. That'll be by churn. And the stacking is two different colors, light blue and dark blue. And that even shows a tooltip. Moving on to the model preview. This is one of my favorite parts about Canvas because it gives you results, machine learning based results so fast. Okay, now that we have analyzed a bit of our data set, a good practice is to have a baseline of what to expect from your ML model training. You can consider this as a score to beat after your data exploration and data preparation. Amazon SageMaker Canvas gives you the ability to get insights from your data before you build a model by choosing Preview Model. Before you build your model, SageMaker Canvas checks your data set for issues that will cause your build to fail. If SageMaker Canvas finds any issues, then it warns you on the build page before you attempt to build a model. The issues that SageMaker Canvas checks for in your dataset and how to resolve them are described in the SageMaker Canvas documentation. To perform data validation, simply click on the Validate button on the top right of your screen. Let's do that. So, validate data. And I think this can take a couple minutes, more like a few seconds. No issues found in the dataset. I guess no surprise since this is a curated data set for us. So now we can proceed with the preview model. We want to get a quick view into whether our target column can be predicted by the other columns. Yeah, I mean, if we're going to get like 10% predicted accuracy, then I guess we don't have the right material to predict the churn. We can get a fast view into the model's estimated accuracy and column impact, the estimated importance of each column in predicting the target column. Okay, let's do it. Let's go and preview model. This can take 2 to 15 minutes, depending on the dataset size. And the reason it goes faster is because it just selects a subset. For our use case, the preview model takes approximately 2 minutes to build. So the first thing the preview model feature gives us is the estimated accuracy. And then it continues working to give us a breakdown of feature importance, which columns or features have the most impact on predicting our selected column, our target column. And as we'll see, night calls will have the biggest impact, then eve mins, then day mins. Let's go back to the beginning of this and see what those are. I'm curious. So night calls are the build cost for nighttime calls. Okay, so this whole time I thought we were doing hotel data because that's what's used in the Data Wrangler workshop, which you can also find here. And this is actually for a mobile phone operator. So this makes a lot more sense. If the cost of nighttime calls is very high, customers are gonna leave that company from one provider to a different mobile phone operator. And then let's see what's the second highest column impact. Eve mins, day mins. What do those mean? Eve mins, the build also has to do with the build cost for evening calls. And then the total number of calling minutes used during the day. So I wonder if a lower amount of use or a higher amount of use contributes to customer churn. I would guess if the customer doesn't use it a lot during the day, they might be more likely to switch because maybe they're not using it because they're not happy with it. We'll find out. Let's see if this is done. Not quite. We'll give it some more time. In the meantime, we can keep going through this. So these feature importances are very useful to understand the impact that features have on our predictions. The higher the value, the higher the impact. If a single feature is extremely impactful on a model's outcome, it's a primary indicator of target leakage, and it's very likely that the feature won't be available at the time of prediction. So target leakage means if there's target leakage with a single feature, then we will want to exclude it. Target leakage, also known as data leakage. This occurs when a variable that is not a feature is used to predict the target. This occurs when the model is built or trained with information known as the training dataset that will not be available in unseen data. Okay, right. So target leakage means that it's probably a column that is only available if we also have that column we're trying to predict on. You're only going to have the information for one of those columns if you have the information for the other. So if you're trying to predict, then you only have the input values, not the output values. Here's a great example of target leakage. So if we're trying to predict whether a patient has such and such diagnosis, then we should exclude any hospital visits after that point because they're all going to have that diagnosis already in the charts. That's from a AWS machine learning blog article from 2021, which I'll link to in the description. All right, so the column impact has finished here, and we can see night calls, eve mins, night charge are the most important, and the voicemail plan and phone, I guess the phone number, have the least impact. So I guess the person's not going to leave a mobile phone operator just because of what their phone number is, because you can always take that to a different mobile phone operator. So that makes sense. All right, build data preparation. We're moving on to the data preparation step of the build phase. So we're in the build phase here. Your machine learning dataset might require data preparation before you build your model. You might want to clean your data due to various issues, which might include missing values or outliers, and perform feature engineering to improve the accuracy of your model. Amazon SageMaker Canvas provides ML data transforms with which you can clean, transform, and prepare your data for model building. You can use these transforms on your data set without any code. That's the whole point of SageMaker Canvas, doing all this stuff without code. And it adds the transforms you use to the model recipe, which is a record of the data preparation done on your data before building the model. Any data transforms you use only modify the input data for model building and do not modify your original data source. So this is great. You can have a repeatable thing because there's a model recipe. The following transforms are available in SageMaker Canvas for you to prepare your data for building: functions and operators, date time extraction, drop columns, rename columns, remove rows, replace values, and filter rows. Let's start easy by dropping the columns that we found out do not have an impact on our prediction. Note, having low impact on the prediction does not mean that the features are automatically useless. While it is true that low impact features might add noise to our model, sometimes these can still be useful to describe specific situations for your use case. Always combine predictive power with your business knowledge to determine which features are actually important or not. It helps to have an understanding of the mobile phone operator industry here. For example, in this data set, the phone number is just the equivalent of an account number. Useless or even detrimental in predicting other accounts' likelihood of churn, and the customer's state doesn't impact our model much. So let's remove the phone and state columns by unchecking those features in the column view. Okay, so here we are in the column view, and there is state. We'll uncheck that, and we'll uncheck phone. And here you can see we're building up our model recipe here on the right. Now let's perform some additional data transformations as well. For example, we noticed in our previous analysis that charged amount to customers has a direct impact on the churn. Yeah, if you charge them too much, they leave. Let's therefore create a new column that computes the total charges to our customers by combining the charge, mins, and calls for day, eve, night, and interval. I guess that's international. Let's see, Intel. Yeah. To do so, we will use the custom formulas in SageMaker Canvas. Right, so I guess these can be combined. Let's start by clicking on the custom formula button. So that's the sigma sign here for sum or functions here. And then we will just add the following text. Let's see what's in here. Day calls times day charge times day minutes plus evening calls plus night calls plus international calls. So we're just adding up all the calls by the rate and the amount of time. Let's call this column total charges and add. Oh, it's already done. Cool. That reminds me a bit of a spreadsheet application, except that after this, we're going to be able to create a model from it right away. Okay, so we got the total charges here. And now we can look at what our recipe is looking like. So to get back to the model recipe, that'll be to the right of the search columns icon. Oh, and it didn't add that step, the total charges. Okay, so I guess I didn't add it. Let's go back to functions and paste in that formula, total charges. And oh, I guess I had to wait for it to finish calculating and then hit add, and then it shows up in the model recipe. Great. Now that we've spent a bit of time preparing the data, let's run the preview again and see if the model accuracy will increase. So I'm going to close the model recipe here and hit preview model. So it was 95.6%. We made 3 changes to the dataset. So we're going to hit update and have it preview the model again. And we'll see if that improves the accuracy. According to the guide here, we're going to get a 0.4% increase in the estimated accuracy. That's a pretty good level of accuracy. So let's go ahead and finally train the model. And Canvas offers 2 build options. By the way, the preview model doesn't charge you for training time. If you look at the SageMaker Canvas pricing page, you're only charged for the console time until you log out. But for quick build and standard build, there is an additional charge for training. But that's why it's great to use the preview model until you've got a pretty good level of accuracy. So quick build builds a model in a fraction of the time compared to a standard build. So you get some accuracy exchanged for speed. And the standard build builds the best model possible from an optimized process powered by AutoML. Speed is exchanged for the greatest accuracy. So that's the trade-off. Since this is our first time running this and we're not trying to put into production, we want to get some results faster, let's just do the quick build. A quick model trains fewer combinations of models and hyperparameters in order to prioritize speed over accuracy. So what we're learning here is that the standard build, it tries a bunch of different combinations of models and hyperparameters. However, the quick build is not available for models that are bigger than 50,000 rows. Oh, and here we go. The preview model has indeed given us back a 0.4% increase in accuracy. And I'm going to go click quick build and start quick build. And now we wait for anywhere from 2 to 15 minutes. Since the dataset is small, this will probably take even less than 2 minutes. And when the building process is complete, the model predicts churn 95.9% of the time. That seems like a great accuracy rate, but let's dive deeper and see if we can trust the model. So on the scoring tab, which is the second tab in the Analyze step, we can review a visual plot of our predictions mapped to their outcomes. This allows us a deeper insight into our model. But first, let's focus on the Overview tab. This is the tab that shows us the column impact, or the estimated importance of each column in predicting the target column. In this example, the duration column has the most significant impact in predicting if a customer will churn. Okay, so this looks like the longer the phone calls are that a customer makes, the more likely that customer churn will be false. We will double check if that's what it means once this finishes building. And by the way, if any of these numbers are different for you, it's because machine learning introduces a level of randomness or a stochasticity into the process, which can lead to slightly different results in different builds. Now, you may be wondering, how does SageMaker Canvas make sure it's not overfitting the model? Does it divide up the data into different parts? Yes, it separates the data set into training and test sets. The training data set is the data Canvas uses to build the model. The test set is used to see if the model performs well with the new data. The Sankey diagram in the following screenshot, that's what this looks like. It links one value to another, showing the flow, shows how the model performed on the test set. To learn more, you can check this part of the documentation on evaluating your model's performance in SageMaker Canvas, as well as the page for SHAP baselines for explainability. Let's go to the Overview tab to review the impact of each column. This information can help the marketing team gain insights that lead to taking actions to reduce customer churn. For example, we can see that both low and high cust serve calls increase the likelihood of churn. The marketing team can take actions to prevent customer churn based on these learnings. Examples include creating a detailed FAQ on websites to reduce customer service calls, and running education campaigns with customers on the FAQ that can keep engagement up. So they don't want too little engagement and they don't want too much engagement. This way, if a customer has too little engagement or too much, they know, oh, this is a warning that they might leave us, and they can take some of these actions. All right, so I had to refresh the page for the model creation to show as complete, and I have a 96% accuracy. To get more detailed insights beyond what is displayed in the Sankey diagram, and again, the Sankey diagram can be seen by clicking on scoring here. Business analysts can use a confusion matrix for their business solutions. For example, we want to better understand the likelihood of the model making false predictions. We can see this in the Sankey diagram, but want more insights. So we choose advanced metrics. That's right here on the right middle. We're presented with a confusion matrix, which displays the performance of the model in a visual format with the following values, specific to the positive class. We're measuring based on whether they will in fact churn. So our positive class is true in this example. True positive, the number of true results that were correctly predicted as true. True negative, the number of false results that were correctly predicted as false. False positive, the number of false results that were wrongly predicted as true. And false negative, the number of true results that were wrongly predicted as false. We can use this matrix chart to determine not only how accurate our model is, but when it is wrong, how often that might be, and how it's wrong. The advanced metrics look pretty good, so we can trust the model result. Why does it look pretty good? Because the false ones, false negative, false positive, are 1 and 2% approximately. These are if the model thinks a customer in the dataset will churn and they actually don't, or if the model thinks the customer will churn and they actually do. High numbers for either might make us think more on if we can use the model to make decisions. Our model looks pretty accurate, so let's move on to the Predict tab. I'll close this and go to the Predict tab. So we could now move on to making a standard build by adding a version here and then running the standard build. But for our use case, let's just start making predictions. But please note, if you want to use the feature of sharing your model with a data scientist, which shares it with SageMaker Studio Lab, then we will need to add version and run the standard build. Now let's do a batch prediction. We'll select the data set and let's just use the same data set we used to train the model. Not a real good idea in reality. You would want to, try this out with a different data set that has the same structure. But for simplicity, for the demo here, for the lab, we're just going to use the same data set. And it's ready. Let's click View on that pop-up down below. And for each row, it tells us the probability, whether it's true or false. And you can even download those results as a CSV. Now, one of my favorite features of Canvas is the single prediction, because this is a great way to explore what if scenarios. Like, what if the day mins is like way more? It was false. Now I'm changing it to way more, and it's still false. Oh, but if the charge is like off the charts more, still false. What if we just, I don't know what type of values it should be. I could go and explore the data for that, but let's just see for fun here. If I increase those by a ton more. Yes, now the customer is going to leave. So those are the type of what if scenarios you can make. Okay, so we finished the lab. If this was helpful, please smash that like button and subscribe for more content on cloud related content, on AWS related content, and leave a comment on what you found interesting about the lab or any questions you had, where did you get stuck, or any future videos you want to see. Thanks for watching. Bye.